Hello, welcome back. We already learned about how to pass data between two functions in C programming using parameters. So in this episode we are going to learn about what are the methods or what are the mechanisms available to pass arguments between two functions in C programming. There are two methods are available to pass data between or arguments passing arguments between two functions in C, which are pass by value and pass by reference. So we already see about how to pass data or how to pass the arguments between two functions in C programming, which is called a pass by value. So we already write programs that contain pass by values, and another mechanism is there called pass by reference. In order to understand what you mean by pass by reference and what is the difference between pass by value and pass by reference, you need to know something about pointers in C programming. Pointer is known as the most difficult topic in C programming, and pointer is one of the most advanced feature of C programming, and in modern languages like Java or .NET, there is no pointer mechanisms are available on this language. So C is very advanced compared to that particular language. But the main disadvantage of the topic pointer is that it is difficult to understand, and the program that contain pointer is not easy to manage, and it is not easy to debug. So in order to understand the pass by value and pass by reference, you need to know something about what you mean by pointer and what is the use of a pointer in C programming. So in this episode, in this program, I'm going to demonstrate what you mean by a pointer and how can we use a pointer in a C program. So first here I declare a variable a, and I assign a value for that variable a equal to 5. So a is a variable of integer type, and I assign a value 5 to that particular variable. So what happens when compiler see two statements like this, a variable declaration and the assignment, the variable initialization? This is called variable initialization. Here we initialize the variable a with the value 5. So what is actually happens when the compiler see two statements like this? Here is the notation of that particular variable declaration and initialization. If you declare a variable like this int a, what the compiler do is compiler just reserve a memory space in primary memory of your computer. So the memories are like rows and columns, or we can say that the memories are symbol slot. Here this is a single assume that this is a single slot of memory, and the memory address is this 262621. This is a memory address corresponding to this memory cell. So if you declare a variable int a, the compiler reserve a memory space, and the memory address is this, and it reserve and it save the memory identifier or the memory variable name as a, and it save the variable name in memory, and this is point to this memory location 262621. This is just a memory demonstration. This is just a demonstration. Actually this memory address may vary based on your computer, or if you run the same program again, this memory address may vary. So if you declare a variable, the compiler just reserve a particular memory space on the primary memory of your computer, and it indicates that particular memory location by an identifier, that is your variable name. So in our case the variable name is a. So what happens if we initialize that particular variable? So here I initialize the variable a with the value 5. So in that case the compiler put the value 5 in that particular memory location. So here the variable name is A and the value corresponding to that particular memory location is 5. This is what happens when we declare a variable and when we initialize a variable in C program. So now come to this program. So here I just declare a variable A and I just put a value 5 in it. So while we working with pointers, we are usually using two notations. The first notation is this symbol and the second notation is a star symbol. These are the two notations we are using in the C programming while we working with pointers. We are already know what is this. This is called the address operator in C programming. We are using this in every program. When we using scanf function, we actually using this. So if for example here is a scanf statement, scanf. Suppose the statement is like this. Okay, the statement is like this, %d, and usually we using the operator, we using the symbol ampersand here and put the variable name. Here the variable name is A. This means we are saved the value corresponding to the variable A to this address of A. Actually the address of A is here, that is 262621. That is the use of ampersand operator in a program. So this operator represents the memory location corresponding to this variable name. Okay, that is the use of ampersand, and a star symbol represents a pointer in a C program. Okay, we will see it later. So this is the address operator, and the star or asterisk symbol represents a pointer in a C program. So here I am going to print the memory address of variable A using a printf function. So printf address of variable A equal to, of course the address is an unsigned integer, so we can use the control word as %u, and here I use the address operator and specify the variable name. Okay, see this statement. Address of variable A is %u. We are using %u because the memory address is always unsigned integer. So here I put ampersand before the variable name. That means this indicate the memory address corresponding to variable A. So if you compile the program, and I'm going to run it. Here we got the address of variable A. The address of variable A is 2293324. That is one of the address of memory location now available in my computer. This may vary if you run the program again, or maybe you can get the same memory address for variable A. This may vary. This is based on particular system memory location, availability of memory in a system, in a computer. This is vary in different systems. Okay, so this is how we get the address of a particular variable in our computer memory. So just use the ampersand operator and provide the variable name. Okay, now here I make another statement, printf /n value available in %u is %d, and I provide the two variable name here. Value available in %u, it is an unsigned integer, so it's a memory location, so I use the address of variable A. Now I have to get the value of that particular memory location, so I just used variable a. So ampersand a will return the address of variable a, and just simply a return the value available in that particular address. Okay, we can check it out. Compile, run it. So here we got the output. Address of variable a is this, and value available in this address is 5. That is the value available in variable a. Okay, so this is the use of an address operator in C programming. Okay, now we come to our point called a pointer. Suppose here I declare a variable like this, int star p. This is called a pointer declaration. Here p is a pointer. The star symbol represents if you declare a variable like this, that particular variable is a pointer. So here the meaning of this variable, this statement is that p is a pointer that contain the address memory location, the address of a particular integer. So if you declare a variable statement like this, int star p, this means that p is a pointer that can able to store address of a particular integer, only integer. It is not possible to save the address of a float value in p, because p is a pointer that points to an integer. If you want to make a pointer that point to a particular floating point value, then you have to specify a pointer like this. Okay, you have to specify a pointer like this, percentage f. So this will indicate that this statement will indicate that f is a pointer that can able to hold the address of a float variable. That is the difference between these two pointer declaration. Here p is a pointer that can able to store the address of an integer value, and f is a pointer that can able to store address of a floating point value. So it is not possible to save the address of a floating point value in a pointer that is declared as an integer. Okay, so here I am going to print these two statements using this pointer. So here I made a simple statement like this, p equal to ampersand a. So what is the meaning of this statement? P equal to ampersand a. That means ampersand a means this will return the address of variable a. So now I initialize the pointer p with address of variable a. So now p contain the address of variable a. So here I am going to make two statements like this, slash n address of pointer p equal to percentage u, and I make a statement like this, percentage u, and it is ampersand p. I save the program, compile it, run it. So here we got the output. Here the address of variable a, we got the address of variable a, and value available in variable a is 5. That means value available to the memory location of a is 5. And here is the address of pointer p. This is not the value of variable p, this is just address of variable pointer p like variable a. So now I made the second statement, printf data available in pointer p equal to percentage u, and here it is p. First I print the address of variable p, pointer p, and now here I print the data available in pointer p. So here I am not using the address operator, so here we got the values saved in the address location of pointer p. So here I again compile it, here I run it. Here the address of variable a is 2293324 and the address of pointer p is 2293312, and the value available in pointer p is 2293324. This is the address of variable a. Here you can see that this is the address of variable a, and the value available in pointer p is the address of variable a. So we can say that p is a pointer that points towards variable a. This is the use of a pointer in C program. So again here I am going to make a statement printf /n address of. So now I am going to print these two statements using pointer p. So I copy these two statements, I copy the two statements and I print it here. I put a separation between these. Okay, now we can identify the two categories. Okay, so here I just use the same statement here, but here I am going to print the address of variable a using pointer p. Okay, so address of variable a is &u, and instead of &a I just using variable p. I just comment the last statement. Now we can check, compile it, run it. Here the address of variable a is 2293324 and address of variable a is 2293324. So we got the address of variable a using pointer notation. Okay, now we have to access the value stored in variable a using pointer. So value available in percentage u is here, address of variable a is p. To retrieve the data available in a pointer, to retrieve the data available in the memory address point by a pointer, just use the star operator and provide the pointer name. So this will return, star p will return the value available in the memory which is pointed by pointer p. Or we can say that star p will return the actual value of variable a. This is quite confusing, but if you try a lot of example you can easily understand the concepts. So star p means it will return the data or value available in that particular memory location pointed by that particular pointer. In this case, the data available in pointer p is address of variable a, and star p indicate the actual value available in that particular memory location. So it is the memory location of variable a, and the data available in that particular memory location is 5. So this will return variable 5, value 5. So again I compile the program, I run it. Here value available in memory location, this is the memory location of variable a, is 5. I hope you enjoy this video. I know that this is quite confusing, but this is just an introduction to pointers, and we will learn the pointer in detail in the coming up part of this tutorial. I just give an introduction to pointer because we need the concept of pointer to learn about. We have to know about the pointer concepts in order to learn the pass by in order to learn the difference between pass by value and pass by reference in function calling. Okay, thank you for watching. See you in the next